This is Chemistry, Unit 2, Matter, Separation of Mixtures. The first technique to separate a mixture that we'll focus on is filtration. This works only for heterogeneous mixtures where one component of the mixture is a solid. So the mixture is poured onto a mesh, such as filter paper, which you can see in this picture, allowing the liquid to pass, which is the blue, and leaving the solid residue, which is the brown, behind in the funnel on the filter paper. This video will be posted and it will help refresh your memory about how to properly fold a piece of filter paper. Distillation is the second technique we'll focus on. This works for both heterogeneous and homogeneous mixtures where one component of the mixture evaporates very easily, so it's considered volatile. Now in this experiment, our mixture is in the test tube on the left. You can see it's got a blue color to it. So this was a mixture of alcohol and water with some food coloring added in, and it's being heated right now. So the way distillation works, the more volatile component, which is alcohol in this case, and this is the volatile component is known as the distillate. It is separated by condensing and collecting it in a separate container. So first it will evaporate, and then it will condense and collect in the second test tube on the right-hand side, which is sitting in an ice bath. Now the distillate in this case should be clear. So that's how you know you completed the experiment correctly. Blue water should be left in the original container, and clear alcohol should be in the container in the ice bath after distillation. Our third technique that we'll focus on is chromatography. This works only for homogeneous mixtures. It is an analytical process. You want to analyze your sample for the separation of homogeneous mixtures. We will focus on paper chromatography, which involves a small spot of solution, which you can see in this original container, the original beaker, containing the sample, is applied to a strip of chromatography paper about 1 centimeter from the base. So you just have to decide where the base is, and that would be in your instructions. And the spot is placed about 1 centimeter from the base. And you can probably, I don't know if you can probably tell, there's lines drawn on here in pencil to indicate this. So this sample is absorbed onto the paper and may form interactions with it. So a good example would be the use of an overhead marker, which is composed of various colors. So as you spot the paper and then you put it in your solution, it will separate the colors from that pen.